Title of this lecture is Blood Cells. Now, we had some information about blood cells already, namely the 3 types of blood cells, which you should already know. What are they? White blood cells, red blood cells, and platelets.
What kind of stuff? And there's like the L something, right?
Uh-huh. We're going to talk about that. Which one of these is the most abundant? Red is by like a lot. There's a bunch of red blood cells. Red blood cells make up what percentage of all the cells? 99.9% of all of the cells are those. These dudes only make up 0.1%. Okay. All right. Let's focus. You have this in your notes from earlier. We're going to expand on this now with white blood cells. White blood cells are also known as what? Starts with an L.
I don't know how to pronounce that.
That's the similar beginning. Leukocyte or something like that. Yes, leukocyte. Leukocyte. Because the suffix cyte very simply means cell. Like thrombocyte, erythrocyte, leukocyte, endocytosis, exocytosis, cytolysis, cytoplasm, exciting. Just kidding. That one's not true. Yes, very much so. In fact, we're going to talk about that today. Leuko, the prefix leuko means, you'll like this, white. Brilliant. There are 5 different types of leukocytes. And they all have slightly different functions from one another, but for our purposes, you really don't need to know them. I'm going to show them to you. You're like, why did you tell me there's 5 different types? Because I think it's nice for you to know that there are 5 different types, but you got a lot of stuff to memorize in this unit, and I don't want to add that to your list. But I'll show you a picture of them real quick. Here's what they look like. And neutrophils, eosinophils, basophils, monocytes, and then lymphocytes. This one kind of looks like an alien head.
So do these all work together to fight diseases, or is one like, do they each have their own type of disease that they fight?
They all work to fight diseases. Each of them specializes in one way or another to do so. Some of them are more prevalent than others, and some of them, depending on the disease, you may have more of them than others. Like, for example, mono is short for mononucleosis. It's a viral condition, but your body responds to it by producing a whole lot of these monocytes. They're called monocytes because they have one gigantic nucleus in them. And that's what that stands for. Mononucleosis, single nucleus. The reason your spleen gets big is your spleen eats these. It tries to get rid of them, and it's eaten too many of them, and it gets huge. And the spleen's kind of smushy anyway, and it's easily ruptured, which is why if you have mono, you can't continue to play sports, because if you get smacked in the side, you might bleed to death. All right, next. Yeah, so on the bright side. All right, white blood cells have a nucleus, which makes them different than the other types of cells. Red blood cells and platelets do not have a nucleus. No other blood cells do. No other blood cells have one. These fight disease through phagocytosis. Hey, cyto, cell, which means cell eating. I don't know if I can illustrate this. What's it look like? They may kick my video off of YouTube for using this music in the background, but I feel like it's necessary. It is, so I'm going to try to illustrate. Pardon, garçon. No, I just want to illustrate it. Here we go. London Symphony Orchestra. Bacteria. Bacteria enter the cell. Here's bacteria. Here's a white blood cell. It's easier for me to show this moving than it is to show the cell moving. It's a little closer, little closer. There's a little dent that forms in the cell right here, like that. That dent gets a little bit bigger and engulfs around it, and then it takes this whole thing into the cell like that, okay? And then something called a lysosome will go, and it will meet up with that thing. And the lysosome is full of digestive enzymes, and when it meets up with it, it releases its digestive enzymes into that little space. They start leaking in here. Dun 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 dun. And that thing gets completely digested alive. And its stuff inside of there spills out into the cell, and the cell benefits from the nutrients of it, so he's happy. And that's basically phagocytosis in a nutshell. And it's really not the same without the Jaws theme. John Williams made a lot of great music. Star Wars theme, for example, Imperial Death March, Indiana Jones music, Jurassic Park. All right. Anywho, phagocytosis, cell eating. Anybody remember the name of the ball of enzymes? I don't think I said it. Starts with an L. Lysosome. Yeah. Yes. Biology. All right. Normally there are 5,000 to about 11,000. What's the unit here? Yeah, well, sort of. It's a smaller unit, but you get the right idea. Now, what are we talking about? Cells. You're going to get this. I know you're going to get this. Smaller than milliliters. Oh, what's smaller than millimeters? Anybody? You ought to know this. That's a mu. Ooh, bigger than that. Bigger than that.
Micro.
Yes! There we go. Microliters. That's supposed to be a mu. They're like, it just looks like an M or like a U. Perfect. Together, mu. Mu L. Or a mule. Yeah. All right. I'll write microliters so you know what we're talking about. A microliter is 1/millionth of a liter. So milliliters, 1,000th of a liter. This is 1/millionth of a liter. So you should have between 5,000 and 11,000 cells of these white blood cells that exist in a microliter of blood. That's a pretty big range, and that's okay. Ranges are good. It's home for some, you know. Low in this range is good. Low in this range is good. Getting a little too high? Something wrong. Okay? Because the body is efficient / lazy. Yes. We don't want to have more of these than we need because they are hungry. We don't want to create hundreds of thousands of excess hungry cells because they're looking for food. If there's bacteria around, that's a win-win. We don't have to produce food for them. They kill the bacteria. They feed themselves. Everybody wins, except for the bacteria. But we get above that, it has to be for a reason. Okay? So if we get above 11,000 cells per μl microliter, this is called leukocytosis, and usually indicates infection. If they don't know what's wrong with you and you go to the doctor, they'll a lot of times do a blood test. And this is one of the main things they test for. If you have an elevated white blood cell count, it means you're fighting some sort of bacterial infection, even if they can't find it or figure out what it is or where it is. Some sort of bacterial infection. Okay, if it's extremely elevated, leukocytosis is leukemia. Having too many cells that are not working correctly. Leukemia. Cancer of the blood / bone. Whoa. Why would they call it bone cancer? What does blood have to do with bones?
Doesn't it go through your bones?
It goes through them for sure. That's true. Yeah, because all of our blood cells, white blood cells, red blood cells, and platelets are all made in our red bone marrow. So leukemia is cancer of the blood and of the bone. Okay. So has basically production of huge numbers of abnormal leukocytes. They're abnormal. They're not doing what they're supposed to do, but they are still using the body's resources. All right. Next one on our list is platelets. Platelets are known as what kind of cell?
They clot in blood.
They do clot. In fact, that's what this name means. Thrombocyte. Stands for clot cell. Thrombus is a clot. Cyte is a cell. These are cells and cell fragments that aid in clotting. Now, they don't do it all by themselves. These get sticky when we're bleeding out, and they make a plug to try to close up the hole, but there's other things that contribute. Now, sometimes people have too few or they're not working right. Too few platelets, or clotting factors. And clotting factors are proteins. Therefore, they're manufactured based on our genetic code. Can cause hemophilia. Now, of all the conditions that have been named, I think this one is the greatest misnomer. Hemo is correct because it means blood. What is philia? What now? Philia comes from the Greek phileo, which means brotherly love. And so it means love. So this literally means blood loving. And somebody who has this condition would not love the sight of their blood. So I think this is kind of a misleading term. This is inability to clot properly. Not, you can't clot in the right amount of time, or you can't clot effectively at all. Sometimes people have to have platelets donated. And a lot of times it's genetic, because proteins, again, are coded for in our DNA. This is a condition that was really common amongst royal families, because royal families did a lot of reproduction with other royal people and sometimes within their own family. And so these conditions would a lot of times continue from generation to generation in this. Okay, so we can also go the other end of the spectrum. Too many, and in this I'm going to put quotation marks and explain, too many clotting factors and platelets increases risk of heart attack and stroke. Now, too many is relative, and I'll mention that here. It's relative. What is a good number for a teen may be too many for the elderly. So what is a good number for a teen may be too many for the elderly. You may have the same number and effectiveness of platelets and clotting factors as someone who's in their late 70s and early 80s. But for them, that presents itself a problem. While your blood vessels are stretchy and smooth and wide, theirs are hardened and inelastic, and they're narrowing. So having the same number of platelets and clotting factors means that they're at greater risk for heart attack and stroke. So a lot of times, especially if someone has had a heart attack or a stroke, blood thinners are prescribed. And not in every case, but in a lot of cases. Most common of which I mentioned the other day, Coumadin, which is warfarin, which is rat poison. And one over-the-counter one that's been that way for years, aspirin. They found out that aspirin has blood-thinning effects. It increases the time it takes for the body to clot. So some people started aspirin therapy on their own, like an 81 milligram regimen of aspirin to keep that in their system to make their blood just take a little bit more time to clot. It's been proven, it's been shown to be effective. I scarcely use the word proven in science. And you shouldn't really at all. Nothing's ever proven in science. Okay, I'm going to start red blood cells and then we'll call it a day. So, red blood cells. By far the most abundant. Let's put some hard numbers on this. On average, you get about 25 trillion of these. That's about a fifth of all of your cells. One in every 5 cells of your body is a red blood cell. They are loaded with hemoglobin. There are, in fact, so many, there's 280 million hemoglobin molecules in every red blood cell. 2 more bullet points and we'll call it a day. 280 million of them. Hemoglobin binds to what? Why do we need red blood cells? Yes. Hemoglobin is what actually bonds to the oxygen. Here's the unfortunate fact. Hemoglobin binds more easily to carbon monoxide. And it doesn't let go. Once carbon monoxide binds, it has a hard time releasing from that. Whereas oxygen binds to and releases from and binds to and releases from with great ease, which is great. But once carbon monoxide binds, it doesn't release as easily. Folks, where do we encounter carbon monoxide? Yeah, at car exhaust. Anytime there's any kind of combustion, whether it be a fire of some kind, or the internal combustion of your engine, a candle, anything, anytime there's a fire involved in some way, carbon monoxide is going to be produced in at least some way. We'll pick up with more red blood cell stuff tomorrow.